Our lesson today is about operations with radicals. So we're going to be simplifying radical expressions by performing the indicated operations of addition, subtracting, multiplying, and dividing, and or rationalizing some denominators. So a quick review over here. This is what a radical looks like. The radical symbol is the what you probably call the square root symbol. The index number is the little number that's in the V over here. And the number that's inside, or the expression that's inside, is called the radicand. So our first topic is going to be adding and subtracting radicals. Oops, that was a little too far. All right, there we go. Okay, so two or more roots can be combined using the distributive property if they have the same radicand. So to have the same radicand, that means the part that's on the inside here has to be exactly the same, and that also means that the index or the root has to be the same. Otherwise, they're not alike, and we can't put them together. So here we go. For our first example here, we've got 4 root 72 plus 7 root 8. Clearly, the radicands are not the same right now, but we learned that we could simplify those radicals. So 72 we could break down into... let's see, 72 could be 9 times 8, and 9 is 3 times 3, and 8 is 2 times 4, and 4, of course, is 2 times 2. So 72 could be broken down. That 2 did not come out right. There we go. Okay, so 72 could be broken down as 3 times 3 times 2 times 2 times 2. And we learned before that in order to pull something out of a square root, you have to have pairs of numbers. So for each pair of numbers, I can pull out 1. So I can pull out 1, 3, and 1, 2, and that leaves a 2 on the inside. So that means 6 root 2 would be equivalent to the square root of 72. We do the same thing with the square root of 8. The square root of 8 can be broken down into 2 square root of 2. Then the numbers that are outside the radical can then be multiplied together. So 4 times 6 is 24, 24 root 2 plus 14 root 2. And now the radicands match. They have the same index and the same radicand. So that means that these are what we would call like terms. And we could then combine them by adding the numbers that are in front. So 24 plus 14 is 38. And then we just keep the radicand. Keep the radical along with it. It's kind of like combining like terms. Okay, so we have a couple examples here. If you feel like you know what you're doing, this would be a great place to pause the video and then come back and see how you did. All right, so in order to combine these, we do have to have the same radicand. The index on each of these is the same already, but the numbers on the inside are not the same. So we're going to have to fix this one. 3x cannot be broken down anymore. 3 is a prime number, and x has no power on it. So this one's going to stay just like it is. But for the second one, 300x, I could break down 300. And I could take it down to its prime factors, but I think I want to do this just a little bit simpler. 300 is 3 times 100. And I broke it up like that because I know that 100 is a perfect square. So I could take the square root of this number. The square root of 100 is 10. So this would be 2 times 10. And then that 3x would still be inside the radical. Now I could add, I need to do this multiplication. 2 times 10, which is 20. And now I've got 2 things to add together. The radicals match exactly. They have the same index and the same radicand. So I can just add the numbers that are in front. So 2 plus 20 is 22 root 3x. Now for the second one on here, the radicands are 54 and 24. The indices on the two radicals are the same, so there's a possibility that these two can be simplified and made to look alike, but we'll need to do some work with them. So I'm going to take 54 and break it down. This is a square root, so I'm looking for things that I can make pairs out of. So a couple of numbers that'll multiply to make 54 would be 9 and 6. 9 is 3 and 3. 6 is 3 and 2. So that means 54 has a pair of 3s in it, and then it's got a 3 times 2 left over. So for the pair of 3s, I'm bringing out a 3, and the 3 times 2 left over is 6. So I'm going to write it like this. We'll do the same with 24. So 24, I can break 24 down into 4 times 6. Now again, 4 will break down into 2 times 2. 6 is 2 times 3. So the 2 times 2 gives me a pair, so I can pull out a 2. The 2 times 3 has to stay inside. So I'm pulling out a 2, and there's a 6 left over. Now the two have the same radicand. Same radical, I should say. The radicand and the index match. So now I can add the numbers in front. 3 plus 2 is 5. And for that third one there, this time we have 3 radical expressions being added together. I guess we could call those terms, 3 radical terms. The indices match on all 3 of them. They're all 3 square roots, but the numbers on the inside do not match. So we're going to need to work with them and see if we can break them down. So starting with 18. 18 is 9 times 2. 9 is 3 times 3. So I have a pair of 3s, so I can pull out 1 3 for that pair, and that leaves a 2 on the inside. So this would say the 5 that was already there times 3 times the square root of 2. Moving on to square root of 50 now. So I'm going to take 50. That did not come out nice at all. Let's try that again. I was trying to write too fast. There we go. Okay, so square root of 50. I'm going to break that one down. I think 5 and 10 perhaps. 5 is prime. 10 can be broken down into 5 times 2. So that means I have a pair of 5s. So I can pull out 1 5 for that, and that leaves a 2 left over. So this would be the 2 that was already there times the 5 that I pulled out for the pair. And then I've got a square root of 2. And then this third one, inside the radical, there's just a 2, and 2 is already prime, so that's as far as that one can go. I can't break it down at all. All right, so now I need to simplify a little bit. I've got these numbers that are in front of the radicals that need to be multiplied together. That would be 15 square root 2. 2 times 5 is 10 square root 2. And then 6 square root 2. Okay, so now all 3 of these have a square root of 2 for their radical. So that means we can combine them by doing whatever it says with the numbers that are in front. So 15 minus 10 is 5, plus 6 would be 11. So this one would be 11 root 2.